Okay, sir.
Now sound is clear?
Yes, sir.
Okay. So lastly, we have done this concept of uniform motion. We had made the distinction between distance and displacement, right?
Yes, sir.
We have taken some examples. Any problem
No,
from
sir.
that? Okay. Have you tried some numericals?
Yes, sir.
Okay. No problem from that?
No, sir.
Okay. So you have the test on which date? Your mother has sent the message that you have to take a test.
The test would be on, I think, around the 20th. No, wait.
Okay.
29th or 8th of June.
Okay. 28th of June.
Yes, sir.
Today is 29th
Oh, I'm
July.
sorry. July, yes.
Okay. So next concept is about the acceleration. Screen is visible now? Hello, screen is visible?
Yes, sir.
Okay. Now before diving into the concept of the acceleration, let's check this example. Suppose this is a straight line and a particle is moving along this line. At t equal to 0, let initial velocity is 0. After 1 second, the velocity is 1 meter per second. After another 1 second, the velocity has changed to further 1 meter per second. Now that becomes 2 meter per second, 3 meter per
Alright,
second,
sir.
right? So here velocity is changing uniformly. Velocity is changing uniformly.
Yes, sir.
So this is one case. Now consider another situation. U is 0, t is 0. At 1 second, the speed is 1 meter per second. At t is equal to 2 seconds, speed is say 3 meter
Yes,
per
sir.
second. And at 3 seconds, say the speed is 10 meter per second. Now the speed is not changing uniformly here. Speed is not changing uniformly. Right? One more case you can see.
Okay, sir.
Initial velocity is 0, t is 0. At 1 second, speed is 5 meter per second. At 2 seconds, the speed is 7 meter per second. At 3, the speed is 8 meter per second. Right? Yet the speed is increasing, but again there is a non-uniform variation. Okay. So in your syllabus we are not interested in that, we are interested in only this part. Yet in both the situations we
Okay,
are
sir.
facing what? We are facing the change in velocity.
Yes,
So
sir.
we are defining average acceleration. Now that average acceleration is equal to change in velocity. If it is in one direction, then you can write it as change in speed also, divided by the time interval. Okay, so we are denoting this acceleration or average acceleration as a, and that is equal to the ratio of change in velocity by corresponding time interval. Just like we have described the average velocity, that was the displacement or change in position by time interval. So again we are defining the average acceleration over an interval of time, right? But if you want to define instantaneous acceleration, so that is equal to rate of change of velocity at that moment. So we can't describe this to you right now. In your book or in
sir.
your syllabus, you have to do or handle the situations using this only. When you move to higher classes, then we will be able to handle this instantaneous acceleration. Just like I have described that there is a difference between the average velocity and the instantaneous velocity. Instantaneous velocity was defined for a given instant of time, and the average velocity is defined over an interval of time, right? Okay. Now this is change in velocity, so the unit will be meter per second, and the corresponding time interval, this is second, so the units of the acceleration is meter per second square, right? Also, this is a vector quantity. What type of quantity it is? It is a vector quantity because there is a directional sense that we can associate with the acceleration, right? Is the sound audible? Hello? Hello?
Yes, sir.
Audible? Clear? Any issues?
Yes, sir.
Any issue with
Yes,
the
sir.
sound?
So can you hear me?
I can hear you.
Hello, can you hear me?
Okay.
Yes, sir.
Yes,
No, sir.
yes, I can hear you. Okay. Now this is a situation for the acceleration. See, here we have a car that is accelerating at a rate of 3 meter per second square. So for every 1 second, the change in velocity is 3 meter per second. Initially the velocity is how much? 0 meter per
Yes,
second.
sir.
Then the velocity is 6 meter per second, then 9 meter per second, 12 meter per second. Means for every 1 second, the change in velocity is 3 meter per second. So we will say that the acceleration is 3 meter per second square.
Yes, sir.
Right? If the direction of motion, let me write, if the direction of motion is same as that of acceleration, we say that the speed will
Yes,
increase.
sir.
We say that the object is speeding up. Just like this is the car, it is moving in this direction, means the velocity is in this direction, and if the acceleration is also in this direction, so the final speed, if this is initial speed and if this is final speed, so final speed will be more than the initial speed. Now there can be another situation when the velocity is in this direction and the acceleration is in this direction. So when it reaches here, so in such a situation the final velocity is less than the initial velocity. So this situation is called retardation, or you will say that it is slowing down,
So deceleration?
right? So the best example is de-acceleration, you can say, or negative acceleration. We can take this example. Suppose this is ground. You have thrown a particle in the upward direction. The particle will reach up to the top, right? So at given instant, this is the direction of velocity. But Earth pulls this ball downwards. So the acceleration is in this direction. So in moving from, say, point A to B,
Decrease.
will the speed of the particle will increase or decrease? Decrease. And when it
Yes,
reaches
sir.
the highest point, the final speed becomes 0 now. After that, it will again start falling back. coming to point A back again. So in this direction, the velocity is in the same direction as that of the acceleration. Acceleration is in this direction, the velocity will be in this direction, so they have the same direction now. So now it will speed up.
Yes, sir.
Right? So always
Yes,
remember then when the velocity and acceleration both are in the same direction, so you will say that they are really accelerating, the speed is increasing, and when they are in the opposite direction means there is a negative acceleration, or you can say de-acceleration, so
Yes,
then
sir.
the speed will decrease, right? Now also we can plot this situation on a graph. See, so lastly we did the concept of uniform motion, and there I have taught you that what is the relation between the position and time for a uniform motion. So how
In a
was the
uniform
graph of position
motion,
and time in uniform motion?
the
How
position
was the
and time.
mm-hmm. Hmm. Position time graph, the nature of the position time graph
Oh,
was
uh, are you
like
talking
what?
about distance time graph?
Yes, yes,
Okay,
yes, yes.
but so you're asking me which?
The nature. Mm-hmm.
Oh, okay, okay.
Was it curved or
If
straight
it's
line?
in uniform motion, then it would be straight line.
Very good, nice. Okay, and what about the velocity time graph
Velocity
in
time graph.
uniform motion situation? So distance time graph, you told
Yes, sir.
that it would be a straight line, right? For uniform motion. And what about the
Velocity
velocity
time
time graph?
graph would, if you wanted uniform velocity, then it would be a straight line. It wouldn't go
Yes,
there
yes.
would be no steepness.
Okay, okay. Very good. Nice. So that would be parallel to the time axis, right?
Yes, sir.
It has no steepness, na?
Yes, sir.
It has zero steepness. Okay. Now from here we have inferred one more result, that what is the area of velocity time graph? What is represented by the
Area of
area velocity
velocity
time
time
graph?
graph. Uh, when you times the total time and
What is the shape? What is the shape?
it's
What
the
is the shape of this rectangle?
rectangle. Yes.
What is the shape of this geometry? It is a rectangle, na? So we have to, if
By
we,
by
so try to recall,
multiplying
if this is
by
a rectangle, then
multiplying
to
the
find the
width,
area,
which
what I will,
is the velocity, and the length, which is the
yes,
time, you get the displacement.
very good, very good,
Displacement.
excellent. Okay, you will get the displacement. And also I have told you that if this is a line that is inclined with the time axis, so you
Yes.
can get the slope from here. So what this slope represents? Slope of distance time graph
Distance
represents
time graph, the
what?
slope represents the total distance. This velocity.
Yes, very good, excellent. In the same way, now we are dealing with the non-uniform motion, right?
Yes, sir.
So when you are dealing with the non-uniform motion, the distance time graph can never be a straight line. It will always be a curve, either this or this, right? But if
Yes,
we
sir.
look for the velocity time graph, and I am saying that the motion is non-uniform, but the acceleration is uniform, and in every 1 second, the velocity is changing equally. So at t equal to 1 second, if the velocity is 1 meter per second, and at t is equal to 2 seconds, the velocity is 2 meter per second, and at t equal to 3 second, the velocity is 3 meter per second, right? So if I join all these points, what I will
Yes,
get?
sir.
I will again get a straight line. So here the acceleration is for whatever the
Acceleration
interval you
is
want to
0.
consider. So that is the change in velocity is 1 meter per. No. The acceleration is change in velocity. Whichever interval you
Yes,
want
sir.
to consider, it's up to you. You want to consider which interval. Suppose you want to consider this interval. In this interval, how much velocity is changing? From 1 to 2. So that is
Yes, sir.
1 meter per second. 2 minus 1 na?
Yes.
And what is the corresponding time interval? 2 minus 1. So that is again 1 second. So finally what you will get? 1 meter per second square.
Oh,
So in
sorry.
this situation,
it's
acceleration is constant.
okay. I thought that the velocity was distant, so yeah. Yes, sir.
No, this is velocity versus time. So the acceleration is actually constant. So in your case, we are going to deal with this situation. So from here, you can also write that the slope of velocity time graph gives
Yes, sir.
acceleration. Right? Got it? So it is telling us what? It is telling us about the acceleration. But the motion is non-uniform. But the acceleration is constant. And the
Yes,
best
sir.
example is motion under gravity. This is the best example of motion with constant acceleration, and in that case acceleration under gravity, acceleration due to gravity, that is denoted by letter G, small g, and the acceleration is 10 meter per second square, or sometimes it is also written as 9.8 meter per second square. It is one and the same thing. Okay, so whenever you throw something under the effect of the Earth's gravitational pull, so Earth will create an acceleration. Earth is pulling it downward towards its center, so creates an acceleration, and that acceleration is 10 meter per second square. So in every 1 second, suppose this is a very high building or cliff, you have released a ball. So the initial velocity from that point O, that would be
Yes,
0.
sir.
That is t equal to 0. At t is equal to 1 second, what velocity you are expecting? What velocity will be there if we have an acceleration of 10 meter per second square?
10 meters per
So the
second.
velocity would be 10 meter per second, right? After t is equal to 2 seconds,
20
for the next one
20
interval,
meters per
again
second.
there is a change of how much velocity? So that
Yes,
will
sir.
be 20. Getting this point? So for every 1 second, the pull of the earth is creating a change in velocity of 10 meter per second, right? So the corresponding acceleration is 10 meter per second
sir.
squared. Is that clear? Okay, nice. Now let's solve some problems. You can see the example here. So the car on the right passes post A. This is post A with a velocity of 12 meter per second. If it has a steady acceleration of 3 meter per second square, what is the velocity 5
So it
seconds
was before
later?
12 meters per second. It was
Yes.
27 meters per second.
So that is 3
sir.
into 5,
27
15 plus 12. So that is equal
second.
to 27 meter per, because for every 1 second
Yes,
it
sir.
will change its speed to 3 meter per second. So in total 5 seconds it is going to change a total of 15 meter per second, and initially it was 12, so that would be
Yes, sir.
27 meter per second, right? Okay, let's solve some problems. And also we can design the formula for that. Let me first paste this situation. We can handle this situation like that. This is the final velocity, This is the initial velocity, that is acceleration times time.
Yes.
Okay, in that example, this formula he is basically using. So that formula we can derive from this situation. Let me show you. Yet it is not in your syllabus, but you can very easily do that. No
Which
issue.
one?
This is velocity
What is
time.
not in my syllabus?
Suppose at t equal to 0, particle has certain velocity. This equation.
No, it
This
is in my
equation is
syllabus,
not
sir.
directly written there up to this part. No, it is in my syllabus, but up to this part it is
Yes,
not
sir.
written there. So at t equal to 0, because when you become proficient in graph drawing and all that, then I will tell you, but I am telling you right now. So at t equal to 0, the velocity is u, and because the acceleration is constant, so we know that we are going to get a straight line graph for velocity time situation for constant acceleration. Now let this velocity is v, and that velocity
Yes, sir.
is after time t, right?
Hmm.
Got it? Okay. Now from here you can very easily write that this part is the change in velocity, that is basically what, v minus u, final minus initial,
Yes, sir.
and that is change in time, right? So how we are defining the acceleration? Acceleration is change in velocity by change in time interval, or by the time interval. So what is the change in velocity? V minus u, and the corresponding time interval is t. Now if you solve this, you will get this part, v minus u as t, and v is equal to
Yes, sir.
u plus at, right? So just by using the definition of acceleration, we have inferred from the graph this situation. So how to read this? Now listen carefully. I am saying that I have a particle whose initial velocity is u. Whose initial velocity is u, and it is undergoing an acceleration a. It is undergoing an constant acceleration a. I am saying constant acceleration a. Then after time t, it will achieve a final velocity v. Got it? Initial velocity is u, and if it is undergoing an acceleration a, then after time t, it will achieve a final velocity v. Okay. Now I am considering one more situation from here. So let me rewrite that. That is t. I can write it as v minus u by a, right? Okay. Now if I ask you what is the area, let me write it here so that I can show you in a single space. If I ask you to write the area of this graph, how you will write the area of this graph? Area means what? I am interested in what? I am interested in this part. So this is O,
yeah,
A,
I understood, sir.
B, C.
So I would
D.
first
what is
find
the
I would
what is
first
the
find the
geometry?
triangle's area, half times height times space,
Yes, yes.
and then I would find the rectangle's area, length times breadth.
Very good. Or you can directly use the concept of the area under trapezium, because it is a trapezium structure, na? You know the concept of trapezium? Okay. So, and the area under velocity time graph represents what?
Area under velocity?
Area under velocity time graph is representing time graph. See. Is the cursor visible?
Oh, yes, I see it now.
Displacement.
Yes, sir.
So it is displacement, and the area of under the velocity time graph is what? Half sum of parallel sides, that is u plus v, and the distance between the parallel sides, that is t. So that is the area of the trapezium, right? We can write, okay. Now we know the value of t. This is the value of t. Now substitute the value of t from here into this formula. T T is equal to V minus
sir.
U by A, right? Now if you solve this, what you will get? You will get V square minus U square equals to 2AS.
Yes, sir.
So this is another equation you are getting,
Yes. Yes, sir.
right? This equation is also in your syllabus now. So I'm deriving
So
all
there
the
are three
equations
equations, I believe.
right now. Now,
Yes, sir.
coming to that. Now I'm rewriting this. Now from here, substitute the value of V. So what you will get? 2U plus AT times T. So that is equal to UT plus half AT square. So finally what you will get? UT plus half AT square.
Yes.
Okay. Is that right? So finally what we got? We got three equations that you are saying. V is equal to U plus AT. V square minus U square equals 2S. And S is equal to UT plus half
Yes, sir.
AT square.
So
Right?
these equations are derived from one another.
But one can so these equations are
Yes, sir.
basically we have derived using the velocity time graph.
Yes.
Okay, by substituting and rearranging. But one thing you have to remember, that these equations are to be used under constant acceleration situation. Yet they will not ask you other situations of non-uniform acceleration, but still I am telling you so that I can structure your mind, so that when you move to higher class 11th, so you have an idea that yes, I know this thing, that I have to use these equations only when the acceleration is constant. Other
Yes,
than
sir.
that, you can't use these equations, right? You will never use these equations in uniform motion,
Yes,
because
sir.
these equations are for non-uniform motion, right? Non-uniform motion equations with constant acceleration. So you will use, first you have to identify that is there any change in speed or not. If there is a change in speed or velocity, this means it's confirmed that this is a non-uniform motion, and in order to handle that, you will look that what is the acceleration there. If the acceleration is
Yes, sir.
constant, then you will use only these three equations, right? And if the velocity is constant, this means the motion is uniform, and you are not going to use any of these equations because these are only applicable
Yes,
to
sir.
non-uniform motion, right? You need to identify the motion.
Yes, sir.
Okay. Okay. Now coming to some problem solving. Let's try these questions. So we have a car that travels 600 meter in 30 seconds. What is the average speed? What is the average speed? What is the formula for the average speed?
The formula for the average speed is total distance over total time. Total
So what is the total
distance is
distance traveled
600
here?
and total time is 30, so the answer would be 20 meters per second.
Yes, 20 meters per second. Now tell me, why is its actual speed usually different from its average speed? So that
That is
example I gave you
because on
last time,
different
what is
time,
the reason?
the actual speed can be different.
He is asking that. Yes, yes.
Yes.
Yes, nice. Because the speed is
Yes, sir.
instantaneous and average is to be calculated over an interval. Right, very good. How is
Velocity
velocity
is
different from the speed?
velocity is
What should we
just
say?
magnitude and direction, but speed is only magnitude.
So, or in other words, what you can say,
Yes,
speed
sir.
is basically the
Yes, sir.
magnitude of the velocity only, right? So you will simply say that at a given moment, speed is the magnitude of the velocity, or you can say velocity, just like you have said that velocity is
Yes, sir.
basically speed with the direction. Okay. Third question. A car has a steady speed of 8 meter per second. How far does the
64
car
meters.
travel in 8 seconds? 64 meters. Nice. How long does the car
Uh,
take to travel
it would
160
take
meter?
160 over 8, which is 20, so 20 seconds.
160 over 8, that is 20 seconds. Nice. Fourth, calculate the average speed of each thing in the chart of the travel time on the opposite page. So we will go to this in
A
later.
car has an
Fifth question.
acceleration of 2 meters per second square. What is this? So it's positive.
Plus 2 meter per second square.
So,
For
sir,
your
if
situation, you will
I
use the sign.
don't write plus or minus in the exam, will they like deduct my marks?
So actually, as per your
Okay.
situation, you need to write this plus and minus because for your range of
Alright, sir.
physics, you need to write these.
So, plus 2 meters per second, what does this tell you about the velocity of the car? The velocity of the car is because acceleration is mhm.
Just focus on the situation, what I have told you by giving the example of motion under gravity. For every 1 second, how much was the
Every
change
one
in velocity?
second the velocity increases by 2 meters per second.
So for your case, if I just want to tell theoretically that the acceleration is 2 meter per second square, okay, what does this tell you about the velocity of the car? What does this tell you about the velocity of the car? So in one sense, that may not be, you can say, principally true, but so far your study is concerned, we will say that the velocity is increasing at the rate of 2 meter
So,
per second every second.
okay, sir.
Okay, but in real physics, this is not the right answer actually. Basically, the sign of acceleration will never tell you what is happening to a
Yes, sir.
particle. Okay, so basically it is wrong. I am writing basically it's wrong. So the answer should be that by looking at the sign of the acceleration, we cannot tell what is happening to the velocity. Okay, I'm giving the example. See, I'm taking the downward direction as, say, negative, and I'm taking the upward directions as positive.
Yes, sir.
Okay. Now, main thing here is that these positive and negative signs he is using here to represent the direction or what? Generally, for one-dimensional motion, we consider these signs
Yes,
to
sir.
be representing the directions. Okay. So suppose if this is the terminology, then the acceleration would be minus g, means minus 10 meter per second square,
Yes, sir.
right? Now, when you have thrown the particle upward and it is moving to the highest point where the final speed is 0, okay, now you can say that the velocity is positive but the acceleration is negative, Particle is moving to the highest point and the speed is continuously decreasing and finally it is becoming zero. So in one sense you can justify that because this is
Yes, sir.
retardation, so the speed has to decrease. Okay, but what about the situation when it is
When it
falling
is
back?
falling back because the
Now in
gravity
this
is
situation,
on
because it is
because the
moving in
gravity
the
is on
downward
same
direction,
side, the acceleration increases.
but the acceleration is negative
Uh,
here, na?
yes, sir.
But the acceleration is negative here. But
The
the speed is
speed
increasing or
is
decreasing?
increasing.
The speed increasing. Yes. So basically, this question in itself is wrong. Just by looking at the sign of the acceleration, we can never tell that whether the speed of the velocity of the body is increasing or decreasing. So we have to look for the sign of velocity as well. So we need to know the sign of velocity as well. So we will say that if A and V, if A and V both have the same sign, then speed
What does it mean by
increases,
A and B have the same sign?
right? See, check.
Yes, sir.
Velocity is a vector quantity, na? So there must be direction. See, I am considering the
Yes,
up
sir.
directions as positive. Check. If I am considering up direction as positive, and if you have thrown something in the upward direction,
Yes,
so
sir.
in which direction the particle is moving up?
Yes, sir.
So velocity is positive in that case, but it is pulled in the
Yes,
downward
sir.
direction. So the acceleration is in the
Uh,
downward direction. So the acceleration is negative in that case. So here the
but
the
then why is
acceleration velocity are in
velocity
the opposite
positive
direction.
direction?
So that's why it is slowing down.
I
Because
see.
I
Okay,
have
okay. I
chosen the
understood,
upward
sir.
direction as positive, na? If I am taking up positive, then the down will be negative. Now see, when it is coming down, the direction of motion is basically what? The velocity. The velocity sign is negative, and the acceleration is also negative. So both are having the same sign, yet
Yes.
both are negative, but the speed is increasing, na? Huh. So if they have the same sign, it doesn't matter they are positive or negative. If they have the same sign, this means speed increases, and if they have the opposite sign, the speed would decrease. Okay, but but he is asking about the velocity. So as per the definition I am saying, so you can say if you have 2 meter per second square as the acceleration, then you would say that change in velocity is positive for a given time interval. This means final velocity is more than the initial velocity. Okay, from this definition I am just saying, in principle, just by looking at the sign of acceleration you can't tell, but in principle using this definition as per your syllabus, this will be the answer. Okay, so you will answer accordingly.
Yes, sir.
Getting my point? This is the real physics, what I am telling you. This is the real physics. And what you are learning is a toddler physics. For you to get familiar with the concept of the acceleration and velocity, you can write this. Just like you are told that the earth revolves around the sun. Okay?
Yes, sir.
Earth revolves around the sun, na? Okay, what about the moon? Huh?
The moon
What about
revolves
the
around
moon?
the earth. Yes, sir.
Then moon will also move around the sun because moon is bounded to earth. Okay. So so in general convention, we don't say that the moon is also revolving around the sun, because it revolves around the earth and it is bounded to the earth, so it also revolves around the sun. And in actual practice, the center of earth and moon, the center of mass, actually
Yes, sir.
moves around the sun. Okay, and we say that they move
Yes,
in
sir.
the circular orbits, right? But actually they move in large elliptical orbits. So up to your scale, we are omitting certain things and we are telling you certain facts just to make you familiar and acquainted with the topic. So not to make them too complicated,
Yes,
because
sir.
for that we have to tell you a lot of mathematics also. That is not in your domain. So I have told you both the things, so you will
Yes,
use
sir.
accordingly. Got the point? Okay. Now coming back to the another question 6. A car takes 8 seconds to increase its velocity from 10 meter per second to 30 meter per second. What's the average
Car
acceleration?
takes 8 seconds to increase its velocity from 10 meters seconds to 30 meters second. 20 over 8.
20 over
Yes,
8.
sir.
Okay.
A motorcycle travels at 20 meters per second.
7th.
Take takes 5 seconds to stop. What is its average retardation? Uh, 4 minus 4
You use
meters
this
per second
equation.
square.
Final velocity is 0. Initial is 20. He is asking about to calculate the acceleration, and the time taken is 5. So acceleration would be
Yes, sir.
minus
Yes,
4
sir.
meter per second square. Right? So because there is a negative sign, so we will say retardation. So actually in your syllabus, positive and negative means acceleration and
Yes,
retardation
sir.
actually. Right? So in that sense, plus acceleration
Yes,
means
sir.
speeding up, negative means slowing down.
An aircraft
Eighth, an aircraft
an
on
aircraft on
its
its
takeoff.
takeoff run
Mhm.
has a steady acceleration of 3 meters per second square. What velocity does the aircraft gain in 4 seconds? 12 meters per second. B. If the
12 meter per
aircraft,
second.
yes sir. If the aircraft passes
Right?
one post on the runway at a velocity of 20 meters per second, what is its velocity 8 seconds later? The acceleration is still 3 meters per second square, right? So then that would
Yes.
be 44 meters per second.
Yes.
9.
Excellent.
A truck traveling at 25 meters per second puts its brakes on for 4 seconds. This produces a retardation of 2 meters per second square. What does the truck's velocity drop to? The truck's
Drops to.
velocity drops to mm, we goes
Again, you can
to
use this
so
formula.
here the initial so v is okay. Initial velocity is 25
Initial velocity
meters.
is how much?
Final velocity we don't know final velocity, so that's what we're supposed
Yeah.
to find. Acceleration is deceleration, sir. So do we
Yes.
just write 2 meters per second square? Minus 2 meters. Minus 2
Minus
and
2.
times 4. It's 25 minus 8, which is 17 meters per second.
Good.
Yes, sir.
So I hope everything is clear to you by now,
Yes,
how
sir.
to use these equations and read
Yes.
the statements. Got it? So also it is suggested that you
Yes,
must
sir.
read your
Yes, sir.
books. Okay. So this is motion graph, distance time graph that we have did last time.
Yes, sir.
The gradient or the slope, we have discussed it, right? So that we have discussed last time. Speed time graph, again I have told you, For the steady acceleration, this is the situation that we have discussed today, and this is for the steady speed. Okay, so this is depicting uniform motion,
Yes,
this is
sir.
depicting non-uniform motion with a constant acceleration. Okay, now let's do this
Okay.
interesting question. Let me snip it. I hope after doing these questions and studying these
Yes,
concepts, you
sir.
will also be able to solve the questions from your book also. So ultimate test of the
Yes,
learning
sir.
is that whether you are able to solve the problems or not. Because at the end of the day in physics, what you have to do?
Yes, sir.
You have to write the concept and solve the problems. So if you are able to do that, this means you are learning in the right
The
direction.
distance time graph above is for a motorcycle traveling.
Wait. When such type of questions or graphical questions comes, so
Okay,
you
sir.
have to be very careful and read slowly first. Now, and because you have a pen and paper exam, so you will write distance time graph. So we'll verify that this is distance, this is time, and also check that in
Yes.
what units it is given. It is meter per second. Because suppose it is given
Yes,
in
sir.
centimeters, then in the final answer you have to
Sir,
convert them. So you have to be very
sir, do
careful.
I always
Okay,
have
so
to
it is
convert
in
it to
SI
meters
units,
per
no issue.
second?
Yes.
Even if the question doesn't state to
Yes.
convert
It is
it.
always
Oh, okay.
yes.
Mm-hmm.
Because it is a standard procedure. In your unit 1, regarding the physical units and all that, you have learned
Yes,
that
sir.
you have to write it in meter per second. Unless it is an objective type question, and unless it is
Yes,
given
sir.
that you should write the answer in that format. If he is demanding the answer in meter per second or kilometers per hour, so then you will write it. Otherwise, it is a
Yes, sir.
standard that you will always use SI unit system, right? Okay.
Okay. The distance time graph
Question
above
number
is for a
1. Go ahead.
motorcycle traveling along a straight road. What is a motorcycle doing between point D and E on the graph? Uh,
Between D
because
and E
so the distance is not increased.
at this point.
The motorcycle is at rest. Yes, sir.
At rest. It is stationary now.
Between which,
Good.
okay, so,
Between which point it is accelerating?
um,
Yes.
it is accelerating.
Accelerating means what?
Accelerating is
Think.
when the
Accelerating
speed is
means what?
increasing.
He is asking. Yes. Good. And from the distance time graph, how we come to
We
know
divide.
about the speed?
So, for example, I do here 10 over 5.
I gave you a graphical idea. Using the graphical technique, you can tell
Yes, sir.
that whether the speed is increasing or decreasing.
Sir, is it A to B? Because there's a
A to
curve
B.
there.
Yes. So how you can tell? Yes, it is a curve there. So if I look for the gradient of the curve, suppose
Mm-hmm.
if I
Yes, sir.
consider one point here, right? And suppose if I consider another point here,
Yes.
so the gradient has increased.
Yes, sir.
The green gradient is more than the red gradient now, and the gradient of distance time graph
Gradient.
gives us what?
Yes, sir.
Slope of distance time. The slope of the gradient of distance
The
time graph
slope
tells us
of the
what?
distance time graph tells us that the speed is increasing.
Yes, no, that it only tells us the speed. So for the subsequent times from here to here, in moving from here to here, the slope is increasing or the gradient is increasing. So that's why the speed is increasing. So when the speed is increasing, so basically this means what? Accelerating. So you will say from A to B, right? Between which points is its speed
B to
steady?
C, as the gradient is same.
B to
Constant, yes.
gradient is constant. B to C.
What
Right.
is
What is this
what does it
steady
mean by
speed?
steady speed, sir?
So you have to calculate that steady speed. Now you are telling that it is from B to C.
Oh,
So
okay,
what is
okay.
that steady speed? Because you are telling that the speed is steady.
Yes, sir.
Steady means constant. You have to calculate
2.5
it.
meters per second. 25 divided by 10
How?
is 2.5.
25.
Because,
How it
oh,
is
sorry, sir,
25?
it's 30. I'm sorry. Sorry, 3 meters per second. I thought it was 25.
So it is 15
Yes, sir.
or 10. It is 10. And this point is 50. So B is corresponding to 10 meters and this is C. So it is 40 divided by how much the corresponding time? 5 to 5 to 15, right? So that is 10. 10 seconds has elapsed. So it is basically equal to what?
4 meters per second. So then,
4 meter per second.
huh?
Huh? See?
Mm-hmm.
Corresponding to B, the position is 10, and corresponding to C, the position is
Oh,
50. See? Because it is
oh,
40,
okay,
it is
okay. So
60.
we're
So in between here it is
understood.
50. It is 20, it is
Mm.
0. So here it is 10. Okay, so from B to C. So the distance
Yes,
traveled is
sir.
40 and the corresponding time check at at the position at it is B is at 5
Mm.
and C it is at 15 seconds. So
Yes,
the
sir.
difference is 10. So it is 4 meter per second. E. What is the distance
Was
traveled
it
between A and
between
D?
A and D?
What is the
60 meters per second. Sorry, 60 meters.
yes, simple 60 meters. What is the
60
average speed
divided by
between A
20,
and
so
D?
3 meters per second.
Right.
Yes, sir.
Now got the points? So this is a very, you can say, interesting question, and hopefully such kind of questions
Yes, sir.
will be asked in your exam. Okay.
Mm.
From the motion point of view, such questions are really important. So interpretation of the graph, how to write it, how to understand, how to read the values. That's why I said, na. So you must read the units properly, and you must
Yes, sir.
read the you can say intersections also. So whenever you are encountering with graph, you have to only think two things. Either think about the area under the graph, or either you should think about the slope or the gradient. Because by looking at the graph, using these two ideas, you can extract most of the informations. Okay. Also, you must be careful about the unit of each graph. Unit along y-axis and unit along x-axis. How much a unit is representing. Okay. So when you are reading a graph, always be careful about the smallest unit involved. So here the smallest unit involved along y-axis. So whenever you have to do the practicals, you will always have to write that what is the smallest unit representing along y. So what one unit along y. So that is equal to what? 10 meters. And what is along x? The unit is 5 seconds. See? Clear? So if you have initially analyze that why one y unit is 10, so then your answer would not be wrong. So you must have you would have calculated it right. Okay, clear?
Yes, sir. Can you hear me, sir?
Hello.
Yeah, yes, sir.
Ha. Okay.
Okay.
Now question number 2.
The speed time graph above is for another motorcycle traveling along the same road. So this is speed and this is time. That was distance. Okay. So what is the motorcycle's max?
no. First write the y. What is the y value?
Meter per second.
What one unit y represents?
Meter per second.
How much? Re-
Uh,
how much? How much? No, the unit is in meter per
oh,
second.
oh, okay, okay, okay.
What
That
is
would be
this
10
gap?
meter. 10 meters per second. Oh, the
No,
one.
no, 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 no. 5.
Okay, okay. Yeah, then 5 meters.
10 is up to here.
Okay.
One small unit. One
X
small unit.
would be
And what
5
is
meters,
x?
5 seconds.
X unit?
Okay.
5
What
seconds.
is
Now
the
go ahead.
motorcycle's maximum speed? The maximum speed of the motorcycle is 30 meters per second.
Right.
What is the acceleration during the first 10 seconds? First 10 seconds, acceleration
First 10 seconds.
would be 10 meters per second.
No, beta.
Acceleration.
Acceleration he is asking. So for the acceleration, you have to look from 0 to 10 seconds. You have to look for the change in speed. So the acceleration is change in velocity. How much is the change in velocity corresponding to that 10-second interval?
Yes, sir.
At t equal to 0, the velocity is 0. And at t is equal to
T
10,
is
what
equal
is
to
the
10.
velocity?
Yes, sir. 30
What is the
seconds.
speed? 30? 30 minus 0 divided by 10 minus 0. So that is 3 meter per second square.
Yes.
For the first 10
first
seconds he is
10
asking.
seconds. I
For the
processed
first
it
10
as 10
seconds,
meters
what is
per
the
second.
yes, yes.
Yes, sir.
Right? What is the de-acceleration during the last 5 seconds? So the last 5 seconds is this 25 and this 20. So from 20 to
Yes, sir.
25, these are the last 5 seconds of the motion. And he is asking us to calculate the
Yes, sir.
de-acceleration during that time.
So we would
So what that
divide
would be?
we would divide 30 minus. Oh,
No,
okay.
simply use that. Acceleration would be v minus u divided by the time interval. What is the final velocity
Final
going from
velocity
20
is
to
0.
25?
Initial
0. Yes.
velocity
Initial
is
is
30. 5 seconds.
30. Time is
Minus
5 seconds.
6
So what's the answer
meters
would
per
be?
second.
Minus 6 meter per second. The procedure you were adopting, so that will lead to only 6 meter per second square. So you have to take the negative sign because it
Yes,
is
sir.
de-accelerating. The speed is decreasing, na?
What distance is
D
traveled
point.
during the first 10 seconds? Distance traveled in the first 10 seconds is
How you will calculate? How you come to know the distance traveled from the given graph? This graph is related to speed time situation. So which information of the speed time graph gives you the distance?
the 30 meters, 20 meters.
See beta here what I
Area
have
or
told you.
slope?
What you have to look for?
Slope. Okay.
No. The slope will give you the acceleration. The area will give you the displacement. Area under velocity time graph gives
Yes,
you
sir.
what? Displacement.
Yes, sir.
Beta, we have just done it today. All the equations
Yes,
that
yes.
I have derived is using the area, na? Okay. So what's the area under this
The
graph?
area for this up to 10 seconds
Up to 10
is
seconds.
30 times 10 times 1.15, sir. Sorry. 30
So this is a triangle.
and
Half into base
only
into height.
100 divided by 150
It is
meters, sir.
150 meters.
Yes, sir.
Okay.
What is the total
E
distance
part.
traveled?
What is the total distance?
The total area.
So you
Yes,
have
sir.
to calculate the area of the trapezium. Half into sum of the parallel sides. This side is how much? 10. 0 to 25. Sum of parallel sides. 10 plus 25
Yes,
into
sir.
distance between the parallel sides. 30. So that is equal to what? 35
Yes,
into
sir.
15. So you can solve this. That much meters. F. What is the time taken for the
The time
whole
taken for
journey?
the whole journey is 25 seconds.
Yes.
Average
What
speed
is
for
the
the whole
average
journey
speed for
is
the whole journey?
35 times 15 divided by 25. Yes, sir.
Very good.
Yes, sir.
Right? You got it? Okay.
Yes, sir. Very clear, sir.
Clear? I hope everything is clear to you. So your homework is try
Okay, sir.
as many questions as you can. Okay?
Okay, sir.
And try to concretize that concept of
Okay,
motion.
sir. Thank you, sir.
Okay. Okay then beta. Bye bye.